So last time we got together, we talked about the first three of those things. We're still in section 1.6. Today we're just talking about number 4. That's got a lot to it. Equations with radicals. So please write this down. Here's the big concept that we're going to be dealing with. All right, don't write this down. Just take a look at it. Up there, I've got an example of an equation with radicals in it. I want to solve for x. How do you do that? These first two steps are the main things. Now, here's where we're starting out. So the first thing I want to do is isolate the radical. I'm going to do that by moving the x over to the other side. That's going to leave minus 15 minus 2x, square root of that. And over here, I'm going to get minus x. So I've isolated the radical. Now, to undo the square root, I'm going to square it. But if I square one side of an equation, I've got to square the other side. So I got to do that. Notice I'm putting parentheses around that minus x because that's the quantity I'm squaring. Based on that concept we just looked at, on the left-hand side, minus the square root of 15 minus 2x times itself is just going to give me 15 minus 2x, which is what I wanted. Minus x times minus x is going to give me x squared. Things just got a whole lot simpler. Well, oh, there it is. So I'm looking around. A couple of you were in pre-cal, 3 of you were in pre-cal last year, and we did some of this. All right, so I want to get everything on one side, so I'm going to move the 2x over. And I'm going to move the 15 over. 0. All right, just taking a look at that. Can I factor it? Do I need to use the quadratic formula? What? I can use the AC method. Some of you can look at that and tell what the factors are going to be. Just looking at it, I'm seeing x plus 5, x minus 3. And the AC method would give that to you. Then I set each one of those to 0. We're down to a quadratic solution now. So x plus 5 equals 0. X equals minus 5. That's one of our potential solutions. X minus 3 equals 0. X equals 3. But we have a potential problem. Excuse me. Anytime we square something like we did, we might introduce what's called extraneous solutions, meaning, yeah, you got a solution, but it's not valid. It doesn't work. So we have to check these anytime we're squaring something. So I'm going to take my negative 5 and plug it in, my original. So I've got negative 5 minus 15 minus 2 times negative 5. Does that equal 0? And that's That's the question we're asking when we're checking this. So I've got minus 5, minus, I've got negative 2 times negative 5 is negative 10. Added to the 15 gives me, is positive 10. Added to the 15 gives me 25. Does that equal 0? No, it doesn't. So I know this solution doesn't work. It looked good, but it doesn't work. So I'll try my 3. So I've got 3 minus square root of 15 minus 2 times 3. Does that equal 0?
Yes.
So I've got 3. Somebody's ahead of me. Under the radical, I've got 15 minus 6 is 9. Yeah, square root of 9 is 3. 3 take away 3 is 0. So here's our answer. So watch out. Anytime you're squaring something like we did, you can get those extraneous solutions. Here's a similar one. Why don't y'all try this one? All right, Ms. Poole, what's the first step?
Add the square root of 2x plus 3 on both sides.
All right. Let's get a different color. Leaves the x over here. Over here, we've got this. Thank you, ma'am. All right. Step 2. Riker.
Square both sides.
Yes, sir. And that's going to give me x squared. And that's going to give me 2x plus 3. At this point, we've got a quadratic equation going on. All right, thank you, Elijah.
Get all the variables to one side.
All right, so I'm going to leave my x squared there because that's the biggest exponent. I'm going to move the 2x over. I'm going to move the 3 over. Thank you, sir. Then we can factor it. We can use the AC method. Some of you can look at this and tell me what the factors are. Anybody want to volunteer?
X minus 3 and x plus 1.
Let's go with that. Thank you. So I set each one of them to 0. So there's one potential solution. There's our other one. We check them because we squared something. So I'll take the 3 first. I've got 3 minus does that equal 0? Make sure I copied it right. Yeah. So I've got 3. Under the radical, I've got 6 plus 3, so that's 9. I'm going with a yes on that one. How about y'all? All right. So there's a potential solution. That is a solution. I'll try my next one. So I've got minus 1 minus 2 times minus 1 plus 3. Does that equal 0? Negative 1. Under the radical, I've got negative 2 plus 3, which is 1. Yes or no? Nope. Because this is minus 1, this is minus 1. No, it does not. So we know this was an extraneous solution. So only 3 will make that original equation true. So those are the steps you have to go through. Isolate, square, solve, check. Something different about this one. A little bit anyway. Notice step 1 is already done for us. The radical's already isolated. So now we got to do what? Square both sides. We're squaring to undo that radical, the square root. But now, what am I going to get on the right-hand side? Here's how it's a little bit different. Henry?
Quadratic equation.
Well, I'm going to square both sides, so I've got to do this. See, I can't just square 3x and then just square 5. I've got to square that whole side. So on the left-hand side, that works out nice. That just gives me 3x plus 7. But on the right-hand side, you can FOIL it, or you can say, well, that's going to be a perfect square trinomial. So that's going to be my first term squared. That's going to be my last term squared. I multiply the two terms together and get 15x, and then double that. So I can do it that way. Or I could FOIL, if you feel more comfortable with that. And so I do this and I get 9x squared. I do this and get 15x. I do this and get 15x. And I do that and get 25. Well, these two add together to give me 30. So either way, I should get the same thing. If you're more comfortable foiling it, by all means foil it. But if you see the pattern that that's going to be a perfect square trinomial, you can use that. Okay, so I'm down to here. Now I'm just collecting like terms. So over here on the right, I've got my 9x squared. I've got 30x and I've got 3x. So 27x. I was having a problem with my signs last period. So, and then I've got 25 and 7. I get that. So I've got 0 over here. Okay, any suggestions at this point? Good call, Parker. Divide by 9. So I've got x squared plus 3x plus 2. And again, I could use the AC method. Or I can just look at that and go, well, x plus 2, x plus 1. I don't want to spend a whole lot of time on the factoring part because I'm hoping y'all are pretty decent at that at this point. So I'll set both of those to 0. One potential solution. Another one. So come over, original equation, I say 3 times negative 2 plus 7 square root of 3 times negative 2 plus 5. So under the radical, I've got negative 6 plus 7 is that. Over here, I've got negative 6 plus 5. Nope. Check my math. try the negative 1. So I've got 3 times negative 1 plus 7. Does that equal 3 times negative 1 plus 5? So under the radical, I've got negative 3 plus 7, so that's a positive 4. On the right-hand side, I've got negative 3 plus 5. That's a 2. Ding, 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 ding. So there's my answer. Now, sometimes neither one of those will be valid. They'll both be extraneous, which means there is no solution, no real solution. First step, Avery. Square root both sides?
Add 9, sorry.
Okay. She waves it off. So add 9. All right. When I do, I get x plus 2. All right. Thank you. Next step. Who haven't I picked on? Katie.
Yes. Then you would like do the both of them times 2 or to the power of 2.
I'm with you. Thank you. So on the left-hand side, that's the one we wanted to uncomplicate, if you will. So I've got 6x plus 7. On the right-hand side, I can either FOIL that, or I can say square the first term, square the second term, multiply them together so I get 2x, and then double that. If you FOIL it, you should get the same thing. Looking good. Thank you all so far. Gracie. Now what?
Add them together, like both sides.
Okay. So I've got x squared. Bringing 6x across, so that's going to give me minus 2x. I've got 7 coming across, that's going to give me what, negative 3 equals 0. Thank you. And so now then, factor time. Peyton.
X minus 3 and x plus 1.
Thank you. I set each one of those to 0. Two potentials. Start checking. So I've got 6 times 3 plus 7 minus 9 equals x minus 7. I've got, So under the radical, what do I have? 18 plus 7, 25 minus 9. I don't know why I put x there. It's going to be 3, isn't it? So on the right-hand side, I've got minus 4. Over here, I've got 5 minus 9. Does that equal negative 4? Yeah. So there's a good answer. I check the next one, so I've got 6 times negative 1 plus 7 minus 9. Does that equal negative 1 minus 7? Under the radical, I got negative 6 plus 7. That's that. Minus 9. Negative 8. True. So this one we actually had 2 solutions. Just a little bit of foreshadowing. What does that even mean? That means if we graph that thing that we started with, it'll touch the x-axis in 2 places. One at x equals 3 and one at x equals minus 1. Now it's going to be a weird looking thing, but it's going to cross the x-axis at those points. And then we get to this one. Now I'm looking at that. Which one of these, I got two radicals now. I want to isolate one of them because that's all I can isolate because I've got that 2 sitting over there on the right-hand side. Here's my hint. Which one's more complicated? This one. Thank you. That's the one I want to isolate. It'll make your life easier. You can do either one, but isolating the more complex one, if there is one, will make it simpler. So I'm going to subtract. Over here on this side, I've got minus this. That's the one I want to isolate. When I subtract the square root of x, I've got 2 minus the square root of x. Now, at this point, this is real similar to the last two we saw. You just got a radical on both sides. So what am I going to do? I'm going to square this guy. The whole side, notice, I'm going to square this guy. On the left-hand side, just think of that square root of x minus 12 as a thing. It's just a number, isn't it? Just one number. I've got a negative one of those. So I've got negative square root of x minus 12. If I square a negative thing, what do I get? A positive thing. So over here, I've got x minus 12, just like we would want. Now, on the right-hand side, do you want to just say, well, that's a perfect square trinomial, or do you want to FOIL it? FOIL? Okay. So what I'm going to do is say 2 minus the square root of x times 2 minus the square root of x. So I say 2 times 2 is 4. 2 times the negative square root of x is negative 2 square root of x. Then negative square root of x times 2 is negative 2 square root of x. And then negative square root of x times negative square root of x gives me, what does that give me? Just x. Good. All right, so then over here I've got 4. I've got negative 2 square root of x and then another negative 2 square root of x. And then just x, yeah? Now notice that follows the rule for a perfect square trinomial. It's just harder to see because that's square root. All right, I start collecting like terms. Oh, look at this. My x's cancel. So over here I've got negative 12 equals 4 minus 4 on the square root of x. Now I'm back to where I was in the other kind of problems. See, I've got to repeat my steps. I want to isolate the radical and then solve for that. So this just takes doing the whole process twice. So I want to move the 4 across. So I've got negative 16 equals minus 4 on the square root of x. Now there's a couple of ways we could do this. because 4 will go into 16, could I divide both sides by negative 4? Sure. So over here I get 4 positive, and over here I get square root of x. Now that works when that number in front of the radical will divide into the other side. It doesn't always, then we'll do something else. So now what? Square both sides, all right, so I do that. And so over here I've got 16 equals x. Only one potential solution. So let's check it. So I've got square root of 16 minus, I'm going back to the original again now, minus 16 minus 12. Does that equal 2? 4. Under the radical, I've got square root of 4. Yeah? Things are not looking good. Oh, they just look better. So done and done on that one. Please notice we just had to repeat the whole process. Now, the thing about this one is both those radicals are about the same level of complication. We've already got one of them isolated over here. So let's just go with it. So on the left-hand side, I've got square root of, this is going to look weird. I've got this. I'm going to do what we did before. I'm going to square both sides. So let's FOIL the left-hand side. So I've got square root of x plus 5, which is just a thing. Okay, here's the deal. If this is just a thing, I'm multiplying that thing times itself. What should I get? X plus 5, because of that concept we talked about earlier, right? So I'm getting x plus 5. Then I'm multiplying that thing times 2. Well, it gives me 2 of those things. Then I'm multiplying that thing, then I'm multiplying 2 times that thing. So I get another 2 of them. Then I'm multiplying 2 times 2. Still a perfect square trinomial, but you'd never know by just looking at it. So what does that give me? Well, it gives me x. Then I've got a 5 and a 4. And then how many of those things do I have? Got 2 and 2. Like that. So over here on the left-hand side, I've got x plus 9 plus 4 of those things. On the right, I've got x minus 1. Stop and think a minute. Does that make sense? All right, so my x's cancel. So when the smoke clears, I've got 9 plus 4 of these guys equals negative 1. I'll bring my 9 across, because now then I'm back to, I want to isolate that radical. So I've got 4 equals negative 10. Now notice, that 4 will not go into 10 like that 4 and 16 did earlier. So what I'm going to do is just square both sides. That radical's not totally isolated, but I can square both sides. That means squaring that whole side. So that 4 has to get squared also. That's where you're going to make a mistake. That's 4 has to get squared. So 4 times 4, even I can do that on my good days. That's 16 times x plus 5 equals negative 10 times negative 10 is 100. So I've got 16x plus 80 equals 100. 16x equals 20. X equals 20 sixteenths equals 5/4 is what I'm getting. I want you to see another kind of problem. 5/4 is a decimal be 1.2. 1.25. Leave it as a fraction. That's a perfectly good number. Let's look at one other kind. Nasty looking, right? I promise this is the kind you want to see on a test. It's cube root. But that same concept we talked about at the start of class works here. So what am I going to do? Cube both sides. What does that give me? Exactly. Oh, that worked out well. So I subtract 2x from both sides. I subtract 3 from both sides. I can go back and check. But I just wanted you to see those cubes are really not bad. At least that one wasn't. If I gave you a cube root one, it wouldn't be any tougher than that.